can see everything now?
Yes, sir.
Yeah, I'm so sorry. So I'm saying if we have y is equal to x to the n power, what would the derivative of y be equal to based on the rule? Tell me what we'll do there. This one we're looking at. Come on, we just got the rule. What do? We have the base, we have the exponent.
That would be the d over
Yeah,
dx.
d dx. Yeah, d dx. Which is the same as saying the derivative of y. It's the same thing. Yeah, so what do we do with n?
Sir, I'm not sure, but do we take the n and multiply it by the base?
Yeah, that's what we do. There's a coefficient here. We know the coefficient is 1. So it will be n times whatever the coefficient is, n times x, and then what happens to this n?
So you have to minus 1 from the power.
Yeah, we subtract 1. So this is basically what happens. So let's apply this to this part here. If we are finding derivative. Remember, this is what we just found using first principle. I just want you to see what's happening. So the index is 2. So what will we have here when we're doing the derivative? What will be our answer for this part?
Sir, 10x.
Yeah, because we have to multiply by the power. So 2 5s 10, 10x, and what will happen to the power?
Sorry, minus 1 from it.
Yeah, so 10x to 2 minus 1. That's basically what we do. Then we come over here. Minus. Same thing. What's the power here?
Sir, 1. No, 0,
Yeah.
sorry, or 0.
So
I'm not sure.
Sir, can I ask the question?
Yeah, go right ahead.
So since we have the power there, we're not using the rule of indices
Yeah.
because
So the power is 1. Isn't that so?
so that's squared and the arrow that you drew there,
Yes, sir, the power is 1.
it's
Wait,
not.
here?
No, at the top. At the top,
Yeah, here.
yes.
Yes.
So when you said you multiply 5 by 2, it's not 5 by 5?
No. We are taking the index and multiplying the coefficient. That's the rule. We're not dealing with laws of indices, right?
That's
This
what I
is
just asked.
yeah,
Sir.
no, I'm answering your question. Please don't be offended.
No, sir, that's okay because I got confused there.
Yeah, right. So what we are doing, that's why I was asking concerning this before I started. This is the index and this is the coefficient. So you're multiplying the index by the coefficient. Are we clear there?
Yes, sir. Make a note of it.
Wonderful. And that's why we're doing what we're doing. Feel free to ask. So it's 2, the index again, times the coefficient. So it's 2 times 5, that's how we got our 10. And then we take 1 from the index. That's basically what the rule says. Are we good so far?
Yes, sir.
All right. So let's look at this now. So I want someone to tell me what is being multiplied by what.
Sir, 1 by negative 2.
Tell me what to do.
Sir, it can be negative 2.
Well, since the power, which part? Sorry, the minus 2x.
Yeah, that's where we're at. Yeah, go
Since the
ahead.
power is 1, it would be 1 multiplied by 2.
Great. So we'll get
We
2.
get back 2x.
Uh-huh.
And
2x.
I'm not sure if I'm correct, but is it 1 minus 1 as the power?
Yeah, that's exactly what we have to do. We always take 1 from the power. And there's a reason why I left it like this, because I want you to see what will happen. So this will become, as we simplify, this will become 10x. Isn't that so? 2 from 1 is 1. So it would have been 10x to the first power, which is the same as 10x. Agree or disagree?
Agree, sir.
Anybody else agreeing?
Yes, sir, I agree.
Yeah. Now look what will happen here. Now we're going to laws of indices to understand this. What is 1 minus 1?
0, sir.
0.
Good. So this will become x to the 0 power. Just want you to see. And we know that x to the 0 power, any quantity therein raised to the 0 power should give us what?
Equal to 1, sir.
1. Therefore, our final answer will be 10x minus 2. Is this clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir, that's clear.
Yeah.
Yes, sir.
So basically, and did we get this answer before? Look carefully.
Sir, yes, sir, we
Yeah.
did.
Yeah, because we had used the first principal differentiation when we use x plus h and all of that, and this is the answer we ended up with. So after a time, mathematicians realized that, you know what, rather than going through this long process of first principle, there is a pattern here. Just multiply the power by the coefficient and subtract 1. So this is the shortened form of finding the derivative. Is that clear to everyone?
Yes, sir. Fair question. Is there
Yes,
times
sir.
like when one method cannot work for the other?
Correct. Well, in this case here,
And in this case,
In
both
general, in the
methods
course.
work for the same. But I'm asking, is there like in future times to find the derivative, you don't have a choice between the methods?
I haven't found such a case with yeah, with force principle and the power rule, because the force principle is actually how we actually derive the power rule, right? But there will be times when you will see functions that we cannot apply this power rule to. We'll have to do something else, and that's why we move on to the product and the quotient and the chain rule. So as we see a function, we'll assess and say, you know what, we cannot do this. We have to do something else. Okay?
Okay,
Sir,
sir.
just another question.
Yeah, go ahead.
So, like how we have both questions that we were able to use the first principle and the power rule. In exam, if we use either one, that's cool.
Definitely. But again, right, we usually don't use force principle unless they ask us.
Oh, okay.
Yeah, they will say differentiate by force principle. If they don't say force principle, I'd say don't do it. It's too lengthy. Right? They usually ask us to do it that way. So if they ask you, do it. If they don't ask, if you just say find the derivative, you use the power rule if it's applicable. So let me show you fast track now how we use this rule. So let's say y is equal to 8x squared plus 5. Now let me not use square. Let me use probably to the third power, yeah. That's 5x squared minus 3x plus 2. Right. So let's take each term. So I want a different person to tell me the answer. We're applying the power rule. So I want someone to give me this first one. What will it be?
24.
Good. 24x. I'm listening for one more thing.
To the second
The
power.
power will be 3 minus 1,
And that will give us
2.
good. So you don't have to go through this rigorous process. I just did this so that you'll understand why we ended up where we are. Right? So that's what I'm showing you now. Once you get the rule, you just apply 3 eighths 24 and you less the index by 1. So we're done with this part. Next. Someone else, the second term.
10x, sir.
10x. Wonderful. Any question concerning this? Anyone?
Sir, so we don't have to necessarily show the working.
No. Hear what? A question like this goes for 1 mark. Why are you showing all of that?
Okay, sir.
You understand? But I just did that so that you can understand it.
Yes, sir.
Are you following?
Yes, sir.
Yeah. All right, so someone else, the next one.
3, sir.
Very good. All right, and someone else, the next one. Mhm.
Zero, nothing, sir. 0.
You know why it's 0? You were correct, but you know why it's 0?
Yes, sir. Yeah, it doesn't. There's no x storm.
There's no x term. That's
X
why
storm.
it's
It's like
0.
x is at 0 there. So when you minus the 1.
All right. Very valiant effort, sir. Valiant.
Yes.
All right, so I'll show you why. It's actually 0. It's a constant term, and when we differentiate a constant term, we'll get 0. But I want you to see why it's that, right? So I'll show you. So this is x to the first power here, and this will be, look at how we're going, 3, 2, 1, x to the 0 power. Are you following? Will this change the value of this term if I put x to the 0 power?
No, sir.
Because x to the 0 power is 1, so this will be still 2 times 1, which is still 2.
Yes, sir.
Mm.
Everyone agrees with that? Just let me know.
Yes, sir.
Good. So if we apply the rule, I have to multiply the index by the coefficient. What is 2 times 0?
0, sir.
0. And x to the 0 power is actually 1. And even if I subtract it and I'm left with x to the minus 1 power, 0 times anything will still give me what?
0, sir.
0. And that is why when we differentiate a constant term, we will always get 0. Right? So I just wanted to show you why it's 0. Once you differentiate a constant term, you will always get 0. So this is 2. And we'll have 0. You don't have to put plus 0 there. It makes no sense. So basically, this is the answer that we will get. Is this clear with everyone?
Yes, sir.
Yes, sir.
All right, so I want you to practice 1. So let's say the function f of x is equal to 3x to the negative 2 power plus 5. All right, let me don't put the negative yet. Scare nobody. Negative 1 power. This x is negative 1. Right? Plus like somebody guess our vex, man. Why are you doing this? Is who mash my toes, man? So let's try this. So I'll give you 2 minutes to try this. Ready for it?
We'll make a try, sir.
Mathematician? I want to hear one mathematician saying something.
We will try, sir.
Wonderful. That's the spirit. All right, so take 2 minutes and let's see what we'll get. Right, this is the original function. So to show it's a derivative, I write f prime of x, right? The derivative of x. Or the derivative of the function. Not of x, it's actually the derivative of y. So it's the derivative of the function. Wait, so who would like to give us the derivative of the first term? We can do the terms separately. This is actually the
Sir, 6x.
Darish, why you take the hardest one, boy?
Yes, sir.
Okay, so it's 6x. Great. So who's next?
Sir,
Come
can I
on.
go?
Teacher, stop. Who's that? Darish again?
Yes, sir. Sir, I have plus.
No.
Okay.
Let's let someone else, please. Who's next? Come on, just apply the principle.
So I have plus 5x to the negative 2 power. I don't know if it's correct.
Man, how you will know if it's correct, sir? So tell us what you did.
That's what I have.
Tell
to
us
say.
what you did.
Since the
Correct.
power is negative 1, I multiply it by negative 5. Two negatives give you a positive. So you
Good.
get
So
plus
it has to be
5x.
right. It
And
has to be
negative
right.
1 plus negative 1, you add two negatives, so it would be negative 2. Negative 1, negative 1. So
Aye, good. Very good. Because negative 1 minus 1 is negative 2. So you're right. So you know, I like how people speak with confidence. Once you're doing the right thing, it got to be right. Okay? The principle is multiply by the power and subtract 1 from the power. You can't go wrong with this. Is that clear with everyone?
Yes, sir.
Good. I want to hear confidence in answers. Once you follow the rule, you can't go wrong. Now, this final one, we have to employ the laws of indices. We know that square root is actually, let me go back here. Right, so let's say we had the square root of 9. What's our answer?
3, sir.
3. Now, the square root of 9, this is actually the 2 here and the 1 here. Because we know square root means there's a 2 here. So the square root of 9 is actually 9 to the half power. This 1 here and this 2 outside. So 9 to the half power, you see again algebra is coming in here, is the same as 3 square, because 3 square is 9 to the half power. Does everyone agree with this?
Yes, sir.
I want to hear one person saying yes. Come on, I need to hear someone else. No one else?
that's right, I agree.
Why I'm doing this, I want you to understand why we do what we do. You know, I could just give you the answer, but that's not my style. So the square root means to the half power. That's the point I'm trying to make. So if we had worked it out like this, we would still get 3. So the square root of 16 is the same as 16 to the half power. Because there's a 2 here for square, and you have a 1. 16 is the same as 16 to the first power. 16 can be written as 4 square. So it's 4 square to the half power. And half times 2 is equal to 1. So your final answer is 4. Are you convinced now that square root is the same as half power?
Yes, sir.
All right. Now we could go to this here. It means that the fourth root of x cubed is the same as x to the what? Someone help me.
3/4, sir.
Very good. 3/4. So this number outside is the denominator and this is the numerator. Are we all good here?
Yes, sir.
Right? So now we can evaluate this the derivative of this. What does the rule say? To find the derivative, what do we do with the power?
Sorry, subtract 1 from it.
Subtract
Be-
1.
Before we subtract 1, what we have to do?
Multiply it.
Multiply it.
Good. So it would be 3/4 of x. The next step.
Or 3/4 minus
Minus
1.
1, sir. 1.
Yeah, and what's 3/4 minus 1?
So negative
Negative
quarter.
Wonderful. Wonderful. So this would be written as we get 3/4 into x to the negative quarter. And this can be written a little differently, but I'm not going to labor on this. Right? But basically, this is what your answer should look like. Any questions concerning this?
Sir, can it also be written as 3 over x to the 4th?
3 over x to the 4th. All right, let me see if I understand what you're saying. So you're saying if it could be 3 over x to the 4th power.
Yes, sir. Or the negative 4.
Negative 4. All right, what it can be written as, that's a good effort. What it can be written as, we know that when we have a negative index, and again, right, I'm showing you that this algebra has a lot of bearings on what we're doing. But before we go into that, right, I just want you to see if we did anything different or strange. I want you to realize that all we did is apply the rule. Multiply by the power, subtract 1. That's what we did here. Correct?
Yes, sir.
That's what we did here. Multiply by the power, subtract. And exactly the same thing we did here. When we found the power as 3 over 4, we multiplied by it and we subtracted 1. So essentially, this is our answer. I just want you to see that there is nothing strange going on. The only thing is that your algebra skills have to come in play. For example, multiplying the sign, subtracting negative numbers using fractions. Right? That is why to be successful in calculus, we must understand algebra well. Most of the time, the reason why people don't get calculus is because of weak algebra. I'm saying all this to encourage us to ensure that some of the basics of algebra that we get it. I don't know who taught you algebra. I don't know how it was done, but I want to encourage you to make sure for your own good, sharpen up your algebra. So we know for the negative index, if I had x to the negative 2 power, how can I write this?
So 1 over x to the 2.
Very good. It would be 1 over x squared. So look at this. We have, and I don't want Darish to answer here. If we have x to the negative quarter power, how can we write this? Someone else. Come on,
1
this is
over x to the quarter, sir.
excellent. 1 over x to the quarter power. Very good. So that's how this can be written. So if you wanted to take it down a bit, again, I'm saying, right, this is the final answer. You don't necessarily have to carry it any further, but if you want to nice it up, it could be 6x plus 5 over x squared. Let me know if you understand what happened there. Anyone understand what happened there? I had x to the negative 2. You see what happened there?
Yes, sir.
Yes, sir.
Right? So it would have been x, it would have been 5 times 1 over x squared.
Sorry, it's like
So
the
5 times the,
so it's like the
Yeah, go ahead.
the reciprocal.
very good. Yeah, so that's basically all in the C, right? And this one here, it will be 3/4 of this x to the quarter will come at the bottom now, right? Because it would have been 1 over x to the quarter. It's just, let me know if you're getting this. This is what we are putting here now.
Yes, sir.
It was 3/4 of it. So if I put back 3/4 in front of it, this is what's going to happen. The 3 will multiply by the 1, and the 4 will multiply by the x to a quarter. Are we good so far?
Yes, sir.
All right. So
Yes, sir.
since we're on this, and since it's a math class, I won't hide anything from you. So if we can take it on one step further, it will be 3 over 4. Now I can write this as a third. The 4, I'm just showing how these things can be simplified down and down and down. The 4 would be will come out here, and the x will come in here. So this is how this is the last phase, how we can write that there. So let me hear what you have to say about this now. Let me know if you want any explanation about this. Remember we were talking about the fractional index? This is where we started, as a fractional index. So can everyone see what's happening there?
Yes, sir.
Right, so it's a lot of algebra, but I want to remind you that our answer is finished here. You don't have to take it further than this unless you're asked to. You just multiply by the power and subtract 1. That is the rule. Everything else I did here was for fun. So let me just let you know. So once you're good up to here, you're good to go. Is this good with everyone?
Yes, sir.
Yes, sir.
All right. So that's the power rule in a nutshell, and that's basically the heart of differentiation. Right? So if you have any function, let's say you start with something, y is equal to 6x to the 9th power. What is the derivative of this? Quickly, let's get it.
Sir, 72 to the 8th. Oh.
6 9s.
No, 63, sir.
Not 54?
63. 54,
Fif-
sir. 54.
Yeah. 54 x to the
8th power.
8 power.
So this is basically the power rule. Are we good to go?
Yes, sir.
One more yes.
Yeah, we're good.
It's a yes from me. So it means we can move on. So who's next? Who's ready to present next?